Right now, there is a very good chance you are eating more protein than you used to. Maybe it's a shake in the morning, a fortified yogurt at lunch, and a heavy chicken breast for dinner, because seemingly everything on the grocery shelf needs to be high protein now. But here is the weird part of this dietary shift. Your body does not simply take all that ingested protein, bypass your internal organs, and turn it directly into bicep muscle. Yet an entire trend has emerged around this exact assumption. It's called Proteinmaxxing, the deliberate attempt to make protein the absolute major target of your diet and to push your daily intake as high as humanly possible. In reality, when you consume a massive amount of protein, your body has to aggressively break it apart, sort through the components, use exactly what it needs in the moment, and figure out what to do with the leftover waste. Human biology is complicated. Treating your daily diet like a mathematical spreadsheet where a higher number automatically equals a better result completely ignores the reality of how your internal systems actually process nutrients. Make no mistake, protein matters. Your body actively relies on the amino acids derived from protein to build and repair physical tissues. For healthy adults, the basic biological requirement, the US recommended dietary allowance, sits at about 0.8 grams per kilogram of body weight every single day. If you train regularly, lift weights, or run long distances, your body undergoes more physical stress, which means you require a higher baseline intake to repair those tissues. That basic logic creates a very tempting metabolic question. If a higher baseline of protein is good for you, does scaling up your intake indefinitely automatically scale up your physical benefits? To answer that, track what happens when you drink a huge shake. It hits your stomach and small intestine, where those large proteins are broken down into smaller pieces, and eventually into individual amino acids that enter your bloodstream. Now your body has a pool of resources, and it starts allocating them. A specific portion of those amino acids is sent off to support muscle protein synthesis, but the remaining amino acids are diverted elsewhere. They are used to manufacture vital enzymes, regulate hormones, and build other necessary proteins your organs require to function. This is the critical detail fitness culture routinely skips. You do not have a giant storage tank sitting behind your liver to save extra protein for later. Your body is constantly breaking down and rebuilding, aggressively managing those amino acids to keep the whole biological system running, not just to build a wider back. If we look strictly at building muscle, it requires a synergistic relationship. Resistance training gives your muscles a reason to adapt, and protein provides the raw materials to make it happen. This animated chart shows a large meta-analysis plotting muscle mass gains against daily protein intake. Notice how the return on investment climbs steadily at first, but the additional benefit to your lean mass eventually levels off, and the curve flattens out completely at around 1.6 grams per kilogram per day. Age, specific training routines, and total daily calories mean that 1.6 isn't a magical, rigid number for every single human on Earth. But the clinical data proves a very clear physiological concept. Diminishing returns are real. At a certain threshold, you are no longer getting a return for every extra scoop of powder you consume. It is exactly like buying 10 phone chargers because one wasn't enough. At some point, you're just decorating a drawer. And biological redundancy has a metabolic consequence. When you force in extra amino acids that aren't needed for making body proteins, your system has to strip away their nitrogen to process as waste, while the remaining carbon skeletons are simply used for energy. This overconsumption creates a displacement effect. If you obsess over hitting an enormous daily protein target, you inevitably start replacing other foods your body actually needs to function, like fiber, whole grains, and healthy fats. Now, we do need to kill one persistent medical myth. High protein intake does not automatically cause kidney damage. In healthy adults without chronic kidney disease, randomized trials show no consistent evidence of kidney injury from a high-protein diet. So, massive protein intake isn't inherently dangerous for a healthy person, but it also doesn't guarantee unlimited muscle. Overloading simply forces your body to process biological waste while compromising your overall dietary balance. The reality is, your body doesn't care about your protein streak. It cares about the total system. It cares about your total energy intake, what the rest of your diet looks like, and whether you are actually giving your muscles a reason to grow. For people who train actively, sports nutrition guidance places the useful, evidence-based range for protein intake between 1.4 to 2.0 grams per kilogram of body weight per day. Research heavily suggests that pushing your intake far beyond the amount required to support your specific training regimen simply does not yield proportionally more muscle mass. Proteinmaxxing attempts to solve an optimization problem using blind addition. But human biology has limits, and your digestive system is a living environment, not a calculator. Your goal shouldn't be to test the maximum amount of a single macronutrient your stomach can physically tolerate. The goal is to consume enough protein to support the specific physical adaptations you want, while actively preserving room for the rest of the nutrients your body requires to survive. The healthiest diet is rarely the one where you maximize a single metric at the expense of all others. It is the one where all the distinct nutritional pieces actually integrate and work together. So, if you are currently pouring a third scoop of powder into a shaker bottle, ask yourself one simple question. Are you actually optimizing your diet, or are you just optimizing one number? If this video helped you understand what is really happening inside your body, like the video so others can find it, and subscribe to Health Science Explained. We're going to keep breaking down exactly what your body is doing behind the popular health claims.